They make me laugh every time. You're on mute.
That's right. No, there's no sound in space.
Except in the movies. Anyway, so it's 1500 or 1700 UTC. This is the DTN working group session, and I think we should start. So, okay, I'm going to have to jump to the slide deck so I can lose picture there, so you get to watch me staring at my screen. So the agenda is published online as part of the meeting materials. There's a URL here, guides for participants, particularly relevant with this being an online session, although given it's now Thursday, one would have hoped you would have participated in a few other things if you were attending all IETF week. If you need any technical assistance, there's a URL there as well. So this being an IETF working group meeting, it is covered under the note well. I am not going to go into a deep legal analysis of this document. If this is your first IETF or this document and the concept of a note well is a mystery to you, you need to read it carefully because you are actively contributing during this meeting and there are ramifications to do with IPR disclosure associated with that. I am not a lawyer, but this document was written by lawyers. Go and read it if you have any queries. Type note well into your favorite search engine and it'll find it. So, Ed, go ahead, agenda.
Certainly. So the working group meeting for the 2 hours that we have is essentially split into two parts. The first part are a series of 4 presentations to talk about some of the work that is going on, and in particular, to have some of the users in our community who are starting to deploy DTN, either to talk about their deployments or to talk about the additional things they want to add in support of their deployments. And then the second part of the meeting, if you notice, it says next steps for the working group and rechartering 40 minutes. We've allocated just sort of a large enough chunk of time to talk through all of the things that we think are candidates for the next set of working group charter items, and then to talk a little bit about how we might prioritize those. We can't do everything in the next recharter. We need to make sure that we take on enough material to move the community forward, but not so much material that it takes us years and years and years before we can start crossing things off the list. And I think that is a large and interesting and complex discussion that's going to take a fair bit of time. So that is the second half of the meeting. With that, I think we can go on to, well, what's the next slide? Is it administrivia?
Yeah, it's administrivia. Sorry, I should have probably put this before the agenda, but I was shuffling slides around at the last minute. So Adam's already put a post on the chat saying we're using CodeMD for note-taking. It's a collaborative platform, so please all help to collaborate. Please all help to try and get accurate minutes, and please don't type all over each other. I had a different working group where the notes somehow failed to merge at all well, and it ended up as gibberish, but to be honest, someone could have been typing gibberish to start with. So a little bit of care. It's not a bad system, but we are global and latency can be a problem. The mailing lists you probably are aware of. If not, they are recorded there. What else have I got? Important last minute slide. So there's been a change of personnel. Magnus Westerland has finished his term as our AD, so a massive thank you to Magnus for helping get BPSec and BPBIS and TCP/CL over the line. And welcome to our new AD, who is Zahed Zaman Saka. I hope I've pronounced that right. We continue to refer to him as Zahed because I struggle with names because I'm an idiot. And also a big thank you for our new working group secretary, Adam Whitaker, for basically deciding he would be happy to take extra notes, and nobody's quite sure what a secretary does, but you're very welcome. And with that, Ed, you sort of covered the charter items, but the key point is BPBIS, BPSec, and TCP/CL are now in the RFC editor queue. This is a huge achievement. Well done, everyone involved, and a massive thank you to the author teams and also the ISG reviewers and everyone discussing the fine points of the feedback. We've done it. It's taken a very long time. But they are complicated things, and I think the working group should be deservedly proud of doing it, and the authors particularly so. As a follow-up to that, the fourth document, which is the BPSec default security context document, has just been submitted to the IESG. We are waiting for reviews. We haven't had any feedback yet on that, Ed, if I'm correct.
That's correct. I think the next step is the AD review, and we've not gotten feedback yet.
Okay, possibly the change in ADs is going to slow that down, and it's probably Zahed's first document to look at, so he will undoubtedly have some questions. Looking at the charter items as they currently stand, we have a charter item for custody, which has sort of been superseded by the bundle-in, bundle encapsulation procedures, so tunneling as part of custody transfer. Scott is going to say a few words about that in a minute, and our intention is to roll that into any rechartering. So to clarify that we're not looking at custody transfer per se as a technology, but probably rolling it into bundle in bundle if that seems the right technology. And with that, that's a repeat slide on the agenda. If we have Scott, would you one thing, I have a copy of all the slides you sent downloaded on my machine. So if you have presentation issues, I'm happier for everyone to present with their own slides, but if there's a technology problem, I can do backups. So Scott, let me attempt to say yes to your request. If you click the request to share slides, I think I can click accept.
Oh, do you mean ask to share screen? Because I do not have the slides up.
Ah, in which case I will switch slides. And I will put the slides up for you.
If you can do it, that's best.
You're slightly quiet.
I just lost Rick.
Yes. We'll see if he reconnects. If not, give me a moment and I can take over and drive. Let's see.
I muted myself for some unknown reason. Let me just find.
Were you about to say that my audio was too quiet?
I was just about to say your audio seems a little quiet to me, but that might have been my audio failing. So,
I can try putting in a headset that may be better, but I thought this would be better coordinated. I don't know.
It's absolutely fine.
But I'm hearing.
Why can I? No, let me just find these. I keep opening these slides and not. Ah, you've named them Solar System Internet. That's why I keep. There we go.
Oh.
Can you see those?
Oh, sorry.
No, it's all right. The tab.
Yes.
I was just staring at a tab entitled Solar System Internet and wondering that wasn't Scott's slides. Anyway, moving on.
Sorry. Okay, so let me press on with this. And the reason that the date on this is so weird is that this is actually a talk that I gave 3 years ago. I didn't do any new slides because really there hasn't been any significant change in the thinking on bundle encapsulation since then. And this is actually a pretty good summary of where we were then on this topic and where we are now, I believe, on this topic. So, and these slides had already been cleared for an unlimited release, so it saved me a whole lot of administrative stuff. So with that as background, can we go ahead to the next slide, the first, which is, I think, a summary of what's in the presentation. I will very briefly go over bundle encapsulation's history. Talk about aggregate custody signaling, which is an elaboration of the custody transfer that was in the original RFC 5050 specification. Go through the current design of bundle encapsulation, and then to whatever extent people are patient with it, I can go through some of the ways in which bundle encapsulation technology can be applied, which I think are actually quite interesting and ingenious in some ways. And then I guess a note on what we can do in the future. So next slide, please. And the next one after that. So the original bundle and bundle specification it dates back to August of 2009. It was put together by some folks at MITRE Corporation who are, I think, well, Keith, of course, is still heavily involved in DTN. Bob Durst is, I think, an amused spectator at this point. It was, the original idea was that bundle and bundle encapsulation would be a bundle protocol application that is living, you can think of it as being above bundle protocol. And the motivations for it were support for content-centric networking, custodial retransmission of multicast bundles, and security tunneling, and especially traffic analysis defense. Next slide, please. Those motivations, I think, are still kind of handy, and they're more or less preserved in later thinking on bundle and bundle encapsulation, which it sort of got resurrected in 2013. I wrote up a draft for it in March, and here the idea was, and it's sort of, it's just a matter of looking at it in a different way, I guess. It's conceived in this draft as a convergence layer protocol underneath bundle protocol instead of an application above it. And that was intended to solve a couple of problems. In particular, the immediate problem it was supposed to solve was disentangling routing from security. It gave us a way of implementing security with a security source and a security destination that it was more rational and more powerful than in the original bundle security protocol spec. It solved a bunch of potential routing problems and ways in which routing and security could conflict. Next slide, please. Taking a step back, at the same time, we've been looking at custody transfer, and in 2015, 2016, we looked at what became the eventual decision to remove custody transfer from bundle protocol. There were a couple of problems with it. One was that custodial retransmission was problematic in a number of ways. The two most prominent being that accurately estimating the round trip time was not possible in the general case because the entity that would be acknowledging the bundle might be the next bundle hop, or it might be 6 bundle hops away. There was no requirement for restricting that. And so you just couldn't really know who was going to receive and take custody. And so you couldn't know when that would happen. You couldn't know when it'd be efficient to time that out and retransmit. Maybe even more of a problem, bundles that were fragmented by non-custodians, the original custody holder would never receive a custody acknowledgement, and the custody transmission would just basically break down. All the same, there were and are some deployment scenarios where a delay-tolerant asymmetric acknowledgement mechanism is needed, and bundle protocol is clearly the way to do that. Next slide. So the idea there was, well, how about just making bundle protocol encapsulation make custody transfer and a convergence layer retransmission mechanism, same as TCP or LTP, that is between topologically adjacent bundle protocol nodes. So you would do custody transfer at the convergence layer. So you'd use bundle protocol as a convergence layer protocol, and oh, well, bundle encapsulation was already doing that. So the concept suddenly became, let's just put custody transfer into bundle encapsulation and use BIBE for both purposes independently or together. That is, it can function to solve some cross-domain security problems with mechanisms for security sources and destinations. And at the same time, it can be the place where we do reliable convergence layer retransmission over asymmetric paths using bundle protocol. Next slide. So taking one more out of left field approach at this, in 2012, there were some folks at University of Colorado who were working on a mechanism for more efficient custody transfer by aggregating custody signals for multiple bundles and sort of tagging the bundles so that the signals could be applied to multiple bundles, and the total volume of custody signal transmission could be sharply reduced, which is very important for some applications where the transmission bandwidth was extremely asymmetric, and there are some space applications, for example, where that's definitely true. In particular, this mechanism was implemented and was used for reliable bundle protocol communications with the International Space Station starting in probably 2014, something like that, and has been very well received. There's a lot of enthusiasm for aggregate custody signaling. Next slide. So aggregate custody signaling has been so successful in operational use on ISS that it seemed to me that the original custody transfer really wasn't necessary, that the ACS can do all the things that the original custody transfer system could do, and can also be much more efficient. And so this new design for bundle encapsulation posted in May of 2018 includes custody transfer in bundle, and in particular it includes the aggregate custody signaling concept in bundle encapsulation. That enables BIBE to operate as an optionally, it's not necessarily, you can turn off custody transfer, but it's an optionally reliable convergence layer protocol under bundle protocol that is asymmetric and can traverse multiple bundle hops, because the endpoints at the convergence layer, which are the sender and receiver, the custody transfer destination, will in turn send their bundles using underlying custody transfers. It's turtles over turtles, turtles all the way down sort of thing. Very bizarre looking stack, but it enables this quite powerful operational mode. The encapsulated bundle can be acknowledged, that is the custody transfer can be used to move that encapsulated bundle between nodes reliably, and or it can be encrypted or signed. The security measures available in bundle encapsulation are merged with the ability to do custody transfer. Next slide. So how does this work? BIBE is a reliable custody convergence layer protocol. And the way we do this is that the payload of the encapsulating bundle, the payload of that bundle is three things: the encapsulated bundle, but that's preceded by a transmission identifier and an expected time of acknowledgement. That is, the sender passes along in the payload of the encapsulated bundle the time that it expects to get an acknowledgement back. And those things can be zeroed out if custody transfer is not requested. The acknowledgement of the encapsulating bundle is aggregated into a new administrative record that is sent in a responding bundle. The expected time of acknowledgement is used as a control mechanism for telling the receiver when to stop aggregating and go ahead and send the aggregated custody signal. The responding custody signal will contain a custody transfer disposition code, same as the original custody transfer mechanism, a custody accepted or else a reason for refusal. And there will be in each acknowledgement bundle, custody signal bundle, a sequence or multiple sequences of consecutive transmission IDs of the received bundle, so that any number of bundles can be acknowledged in a single acknowledgement bundle. If the acknowledgement is not received by the expected time, then the transmission of the encapsulated bundle is assumed to have failed, and the encapsulated bundle can then be queued for being re-forwarded, the same as we would do with other reliable convergence layer protocols. Next slide. In the interest of time, I won't go through all these, but I will suggest that these are kind of interesting ways in which bundle encapsulation can be configured and used. You can, in this slide here, we're showing it doing just custodial reliability. Here the custody signal is being sent from node 2 back through node 62 and 19, which are not taking part in the bundle encapsulation. They're just bundle forwarders, and so they're at the bottom of the stack in this very strange protocol stack. Next slide. Here's cross-domain security, which is bundle encapsulation being used to sign a bundle as it traverses a particularly unsafe segment of the end-to-end path. Next slide. Now, I think the next slide is the same sort of thing, but here, instead of being signed, it's encrypted during its traversal over this unsafe bit of path. Defense against traffic analysis. Next slide. We can imagine a bundle entering a portion of the network that's very heavily used, and during in its local parts of the network, it's an expedited high priority bundle. Once it gets to the trunk line, oh no, everybody else is important too. So the encapsulating bundle may be at a lower or higher quality of service than the encapsulated bundle. Next slide. The same thing. There's a notion in the ION implementation of something called critical forwarding, where there's a extended class of service switch that says this is a really critical bundle. Send it every possible way you can send it, and that could be done end to end. And here we're showing it being done only between the entry and exit points from a particularly unstable portion of the network. Next slide. Multicast, oddly enough, you could do a transient multicast. You could have an end-to-end bundle that is not really multicast, but when it gets to a particularly unstable part of the network, to increase the chance of it getting out and reaching the destination, maybe the entry to that portion of the network encapsulates the original bundle in a bundle that is then multicast to multiple exit points from that portion of the network, and whichever one of those guys actually gets the bundle and can forward it onto the destination node in the stable part of the network, that succeeds. Or there maybe there are multiple copies that arrive, but it increases the chance of successful arrival. Next slide. This is oddly enough a way that you can use this mechanism to do source path routing by encapsulating in increasingly deep layers of network adjacency. Next slide. Oh, and yeah, here's you can do certain combinations of all these things. You can do certified multicast that the certification and the multicast terminates when you leave the network, and the number of combinations is I limited only by the imagination. Next slide. What I would see here is I would urge us to add bundle encapsulation along these lines to the chartered program of work for the working group. The specification is actually not very difficult. Implementation is not very difficult. I think we can get a lot of benefit from it, and I think the ability to reclaim some of the features of earlier iterations of our protocols that we had to abandon is desirable just in itself. Getting security sources and destinations and custody transfer back in a way is I think in itself a good argument for adopting bundle encapsulation. And I will finish right there.
Thanks very much, Scott. Spot on time. I've noted that you're effectively requesting working group adoption of bundle in bundle. I think we will roll that question into the discussion in the second half of the agenda, because I know we've made mention of bundle in bundle as part of that. I'll still make a note anyway. So next up on the agenda, I believe we have Marius Feldman, who's going to talk about his bundle protocol version 7 tests with ESA OPSAT. Marius, are you there? Yes, you are.
Yes, I'm here. Hi.
Can you present your own slides, or would you like me to do it?
Felix will do it. So he will take the second part of the presentation, and Sasi will share the slides.
Go. Oh, I think I have to stop sharing. Stop sharing, and then there we go, Felix, you should have control. So, well, hi everybody. Yeah, while Felix is searching for the presentation and checking how to share it, I can already start to talk a little bit about the next minutes. So so we changed the title slightly because we do not just want to talk about that one test, but there's a preliminary test we did because, well, we did not have any flight opportunity in the meanwhile, and I briefly want to talk about that test as well, and then about the ESA OPSAT test that we did just in December 2020. So before we go to some technical things, I would like to give you some background information. Felix, maybe you start with the next slide, right? So it's some background, that shows how long we already desired at that moment to test DTN protocols in the low Earth orbit. Actually, so we are working intensively on the so-called ring road concept since a couple of years. So it was the guy that was just presenting, Scott Burley, who pointed us to that concept. So the idea is that you leverage low Earth orbit satellites in order to transfer data, for example, from sites that are decoupled from the internet to the internet and back again. So it's a sort of approach for low cost communication networks. And while Scott mentioned that back in I think it was March or February 2013 during a visit of mine at the JPL, so 8 years ago.
And the interesting thing is, first of all, well, for sure, I liked the idea because it's simple, and well, I saw an opportunity to test something practically. And on the other hand, it was a lucky incident of history, let's say, that suddenly two flight opportunities popped up. One of them was from the Technical University of Dresden, where a CubeSat was built, and they were searching for payloads. And on the other hand, well, there was a ESA OPSAT request for proposals that was published in March 2013. So really at the same point in time when Scott mentioned this overall concept in a discussion with me. And we have handed in at that point in time a proposal to practically demonstrate this ring load concept, leveraging the ESA OPSAT. So long story short, at that point in time, we well decided to go for a practical realization of that concept and had the opportunities by hand. There were actually two issues. The first issue is that the project that worked on the CubeSat at the Technical University of Dresden required really simple implementation that can operate on an ARM Cortex-M5 microcontroller, and that leverages FreeRTOS as an operating system, which was, at least to the best of our knowledge, not available at that point in time. And on the other hand, well, it was for sure unclear if this ESA OPSAT will happen one day, and if our proposal is accepted. So we focused in the first place on the TU Dresden experiment, and started to build an own DTN protocol implementation in the beginning of 2014. Fortunately, it was finally decided that that experiment will not make it to the TU Dresden CubeSat, as they want to have very simple payloads only, and our project idea was maybe a little bit too complex for them, and they saw it, some risk in it for their overall goals. So thus, well, even if it triggered the overall development of micro PCN, so a low memory profile DTN protocol implementation, it didn't make it to that experiment. And on the other hand, well, ESA OPSAT was somehow active, but there was not continuous feedback from that opportunity, so we didn't know if it will happen. And that part of the history will be relevant in a second when I talk about the first field tests that we did. Well, time moved on. For sure, we are delay tolerant, so we kept on the track and pushed forward micro PCN. And as it has grown with time, we decided to transform it to a real open source project that is hosted in GitLab. Felix, maybe you can go on. And well, have also fully redesigned it and extended its applicability. So first of all, it was intended to just run on really low profile microcontrollers, but later on we added also platform support for POSIX operating systems and well /Linux, and have developed several convergency layer adapters. I don't want to go into the detail of the architecture and so on, but one thing that will be important in a second for describing the experiment as well is that we well, needed an opportunity for sure to also from the application layer interact with the DTN protocol implementation with micro PCN that was well renamed some time ago to micro DTN. And for that, we have developed a specific protocol, which we named just, as we are not that creative on naming, application agent protocol, AAP for short. And that protocol can be used to transfer typical commands to a DTN protocol implementation, like that you well want to create a bundle, or that well you want to hand over some configuration information. So we defined a set of commands for well typical operations within this DTN protocol implementation. Apart from this, as I said, several CLA implementations have been created, like MTCP or SPP, also over TCP, for example. Plus also the first bundle protocol version 7 implementation has been added to our implementation already quite some while ago. And yeah, with this, well, we have also received some mentioning in the IETF draft document. Felix, maybe you can go on. Skip the next slide about the architecture. So let's move to the first field test. So as I've already mentioned, there were initially two options for testing everything, but well, it took really some time to flight test things on OPSAP. So in the meanwhile, to not get bored, and after having a basic version of micro-DTN / micro-PCN available, we decided to go for a small ESA project to do some field testing, and that project is named CodeSound. It was executed in the mid of 2019, so a little bit more than 1.5 years ago. The idea is that we wanted to build a system consisting of a underwater the underwater sensor network, which transfers data via a buoy system through a satellite link to the internet. So in this case, well, we for sure also had the idea to have the ring road approach within the space segment. However, well, we can also easily use, or could also easily use, existing satellite networks. This is what we exactly did. Felix, next slide. So in this test, well, the idea was then to transfer typical data that you can gather easily underwater, like temperature, like pressure, and so on, via a home-brewn sensor network. And from this sensor network, we transferred the data to this buoy system that I've just mentioned, handed it over to micro-DTN, and then via MTCP and a specific relay that we have built through the Inmarsat satellite IoT network to a remote web service. And from there, it was then transferred via MTCP again to micro-DTN. Yeah, we did some testing. Maybe you can show some pictures on the next slides. I always like to show such pictures here, so it's really, yeah, getting our hands dirty. Maybe also the next one as well, where we did the first bundle protocol version 7 testing in a lake nearby, where we then pulled that overall buoy system as well as the underwater network. So it was a sort of mobile underwater network even through a lake, and transferred data continuously to a monitoring system in the internet, leveraging the bundle protocol version 7. So that was our answer to, well, not having a flight opportunity for quite some years, that we at least were able to play a little bit around with the protocols, test everything, and plug things together, and have some practical experiences. Next slide, please. So, well, then, after really years, finally, the OPSAT was well launched and became reality. Maybe some basic information about that that satellite. It's a 3U CubeSat that was launched in December 2019, and then, well, it took 1 year before experiments were allowed, and our experiment was the first one. So it was a, well, simple ring road concept that was explored. Maybe yeah, some information about the usage of the OPSAT. So in the end, we could start a payload there and connect to a local port, TCP port, and transfer data via SPP to this TCP port. And, well, if a ground station is inside, then the data will be handed over. And ESA offered the so-called ESA Smile Lab, so a ground station in Darmstadt, Germany, in order to fetch the data via some reverse SSH port forwarding. So in the end, well, we were just able to pass SPP packets from the OPSAT to the ground segment. Next slide, please. Based on that setup, we have developed a small scenario. So it demonstrates a ring road approach. The idea is that there is a cold spot, not having an internet connection, and from there we wanted to be able to query websites. So the idea is that there is a remote user that wants to access, leveraging HTTP, a website. And an HTTP request is then transferred via a gateway to micro-DTN that encapsulates the HTTP request in a bundle and hands over the bundle then to the space segment. This handing over is done leveraging a specific component that we call dispatcher. It's also offered as open source if somebody is interested. It's a simple component that rendered it possible to simulate different ground stations, as we only had one. Well, we needed to introduce virtual ones. So the dispatcher then connects at a specific point in time or in a specific time span with one of the micro DTN instances simulating different ground stations. And leveraging SPP, well, as I've just mentioned, we handed over bundle protocol version 7 instances to a micro DTN instance operating on the OPSAT, and then back to the ground where, well, again, some gateway carried for transferring the HTTP request to then a real request to a web server. And from there, well, the path back again was then selected by the OPSAT back to the requesting user. One information about that figure. So you see an ION instance and some information about the DSN on the bottom. So the reason for that is that initially we planned, also in a discussion with Scott, to have an extended version where we wanted to simulate a sort of communication from a ring road realized on planet Mars to Earth, where, well, the DSN would have played a role. Unfortunately, so far there's no feedback on the requests, but we can discuss this with Scott again. But that would be an option for extending the experiment later on. Yeah, Felix will now use the last 2 minutes in order to give some details on that experiment.
Okay. Thanks, Marius. I hope you can hear me. So, yeah, I would like to shed some light on some technical details of this experiment. So what happened during the course of this experiment. So first of all, of course, what we had to do here is to configure all these instances, all these services which we're running. And we can take a look at how we configured, for example, the micro DTN instance on the OPSAT. Let's shortly have a look at the code. So this is just a part of our script which configured and ran the experiment. And what we can see here is that we leverage a small Python tool, AAP send.py, which sends an AAP packet to a given micro DTN instance specified by a TCP endpoint. And this AAP packet contains a destination EID as well as a bundle payload. And the micro DTN instance will then take this and make this the payload of an actual BP version 7 bundle and send it to the specified endpoint ID. And what you can see here is basically the payload of one of our configuration messages. So this is a quite basic, straightforward configuration format that consists of first a command that is this #1 at the start, which just says add this contact to the local contact plan. And then we have the endpoint identifier of our ground station, of our hotspot ground station. First of all, this is addressed or this is reached via a TCP SPP convergence layer, so space packet protocol encapsulated into a TCP connection. And then we have the contacts, which can be added here, where we simply specify one contact by 2 variables that contain the DTN timestamps of the contact interval, as well as a bit rate for calculating the contact volume. And this is also done, of course, for the cold spot contact. And when this is configured, and as well, of course, the dispatcher service is configured with the same parameters, then we can send a request to our HTTP gateway that we can see here. And for this, we leverage curl, which gets set in HTTP proxy. And of course, also quite an increase in the maximum allowed delay for the request, so that we don't run into a timeout here. And then we add simply the URL which shall be requested, and the HTTP contents are then sent to the communication gateway, which will forward them via AAP. The bundle will be generated. This goes to the OPSAT. The OPSAT routes the bundle back via the dispatcher to the micro DTN instance 2, and then it will reach the web server via the communication gateway. And when we take a look at the log files which were produced during the test, we can first of all take a look at this instance micro DTN1, where we see that it first of all receives a bundle payload via AAP. It makes a bundle out of it. It routes the bundle, and shows that okay, the bundle has been scheduled, and then a connection is created to the dispatcher, to the ESA ground station via the dispatcher, and the bundle is scheduled for this contact and sent via this connection. And then we can take a look also at the micro DTN instance 3. When the bundle comes back from the satellite, we see that here again a contact starts with the dispatcher service, and then we get a bundle for a local endpoint, which is then delivered again via AAP to the HTTP proxy, which send the request to the web server. The web server will answer, and then we even get the response from which another bundle is created, and this is sent back to our satellite in this case. Unfortunately, during this experiment, we could not verify the whole return path, as the contact was then simply over. It was a quite short contact, but we aim to test this during our next opportunity, which will hopefully occur soon. So all in all, from this experiment, we can summarize that the bundle protocol version 7, as well as our implementation, worked without any issues. However, what we identified as an issue is that routing and forwarding simply based on timestamps is quite error prone. So in this experiment, we had no mechanism to notice that the actual link to the satellite is up, and so that our bundle protocol implementation can react to this. So the forwarding of the bundles purely occurred due to the timestamps, and of course for this you need a very accurate and precise clock synchronization, which was a bit of an issue for us. Also, what we want to highlight is that a standardized mechanisms for configuration and management would be very good. So on our side, we have this very simple configuration format, which I have shown. In the future, of course, we also want to explore AMP, but I think it's quite important to have something standardized here to interact also with heterogeneous implementations of the bundle protocol. And last but not least, what would be also massively useful for us would be some basic tools which are able to check on the bundle layer the availability of other bundle protocol agents, as well as their operational states. So simply like something like a ping utility, which can be used to simply check whether the instance running on the OPSAT is alive and well. So at the end, we would like to motivate everyone to participate in more practical tests and experiments and collaborate to drive really these things forward. So if you have any questions, feel free to ask, and otherwise, thanks so much for your attention.
Thank you very much, both of you. That was really interesting. It's your conclusions were very interesting, and I think will feed into the discussion we'll have after the presentations, particularly your comment about time-based routing. That's interesting. Do we have any questions? Nobody in the queue, and I'm watching our time. So if not, thank you both very much. And next up, Brian. Are you there, Brian? Go ahead. So, Brian, I have you on the agenda as talking about the UDP-CL. I know you wanted to say a few things about COSI, and there were a couple of slides there for it. I'll let you combine the two. We're compressing time slightly, so you quarter of an hour. Try and fit in what you want to try and fit in.
Sure. I messed up my screen sharing, so I tried again.
It's all right. I have to click again.
Sorry for the slight delay here.
I have them if you don't.
Just trying to get, okay.
Yay.
So I should be coming through now, yes? So the first thing I want to discuss are potential updates to UDPCL. And these are all kind of, at this point, speculation and open for question. But the main idea is that UDP provides some unique behaviors that other transports are not going to have. And the main goal of all of this discussion is, in a sense, backwards compatibility for the very simple use case of one bundle turns into one datagram, it goes away, and the convergence layer is done. And there's a top-level question about BPv6 and BPv7 compatibility and backward support that hadn't been brought up earlier. So a lot of these topics are going to be kind of open questions, at least in the near term. But because of the different encodings between V6 and V7, you can disambiguate them in a deterministic way. So there's not any issue of not being able to do it. It's just a question of what's required. The next area is about unspecified or weak points of the current UDPCL, which is it's very simple and straightforward, but it leaves some things to imagination and to implementation. One thing that I ran into when I was just experimenting with the UDPCL was I was doing some work with the BPSec and with security transports, and when things like certificate change are involved, the size of the bundles were starting to approach or exceed the path MTU on my network, which is not that big. 1,500 to 1,200 bytes is kind of a typical MTU. So in the individual draft that I posted was a very, very simple, unacknowledged still way of doing convergence layer fragmentation. And the other thing that's not mentioned in the original UDPCL was how unicast versus multicast are to be used, and BP agent level interface details like should an agent or must an agent choose what network interface a bundle be transported on, things like that. And then the next topic is about extensibility and interoperable security. In the same way as the updates to TCP/CL involved a lot of discussions with IETF best practices and around security and TLS. It seems like this is a reasonable thing to at least specify in the same vein as TCP/CL, where it is here's how to do it when you're configured to do it, but nobody's saying you have to do it. And again, the goal is this send and forget type of strategy with this convergence layer, is that it's very simple, it's straightforward. There's no convergence layer acknowledgements. It's the bundles go out and something else worries about acknowledgement. And also doing congestion control, things like that. The last thing I ran into when I was looking at some other similar protocols was bundle packing within datagrams for efficiency purposes. Right now, the UDPCL very explicitly says one bundle, one datagram. But if you have very small bundles, does it make sense to allow packing to fill up datagram sizes? And then the last thing that I had run into and hadn't written anything up about this yet is in circumstances where an agent is behind a NAT, I can't open up a port arbitrarily, but what I can do is I can establish a UDP conversation that's going to get through a firewall and through a NAT, and that I can potentially advertise, here I am, are there any bundles for me, in the same way as that the TCP/CL allows bidirectional communication. Allows but doesn't mandate. So I did post an independent draft, and I had some really minor last edits that I had made, but I got cut off by the data tracker freeze. but it covers a lot of these topics: unicast, multicast, fragmented transfer, DTLS use, and also I open up a bunch of different issues on these specific topics here about bundle packing, about fragmentation above and below. MTU discovery is a thing that you run into when you start dealing with packetization at a datagram layer, and then advertised return path, and the this last one is about conversations, that when you're trying to troubleshoot or trying to analyze things. Right now, the UDPCL doesn't say anything about if I'm communicating with a peer node, should I always use my same source port number when I'm communicating with them? It's an ephemeral port, but should I use it consistently, or does it not matter? So those are all my topics for the UDPCL. Let me check my time quickly. Got a little bit of time, so I can go on to questions or any discussion topics.
Go ahead, Magnus.
Yes, one question. You brought up NAT and firewalls here. I assume this is, you want to maintain that this is simple in regards to what you're trying to achieve, but maybe you actually want to discuss free usage of stun and turn here to achieve those NAT traversal capabilities. If you can lift that up, it's of interest.
Yeah, I had looked into those as topics, and things like that rely on some specified behavior, such as using consistent port numbers or accepting return path behavior. That right now the UDPCL doesn't mention at all about source port numbers or possible return path. So using things like stun and those kind of related strategies would rely on some more well-specified behavior, such as discussed in this ticket.
Yeah, I mean, in general, if you're going to have bidirectional communication through a NAT or firewall, you're going to have some restrictions to how you transmit. So your outgoing traffic through the NAT has a return path. So, but maybe I don't know if really you need to, how complicated you want to do this, and I'm probably maybe keeping it on the simple side for those particular use case, which is more like, okay, it's multicast, is it one way? Yeah. So.
And the current draft doesn't mention anything at all about return path. So this specific item is really just asking, is there enough value in operating a node behind a NAT or behind a firewall? Is there even enough interest that it's worth investigating, or just leave it unspecified as currently?
So Rick, with my personal hat on, I'm with Magnus. I think taking the steer from stun and turn and those sort of NAT punching technologies is worth doing. Bidirectional capability I can see being useful, particularly in that environment. And I think DTN has uses on domestic terrestrial internets for messaging services and so on. And in those cases, you're going to get firewalls and nets and all sorts of horrible domestic broadband kind of things in the way.
And that's why I read into this was just on a private network that has a restricted firewall. That's just how things.
Magnus, does that cover it? I shall move him.
So I have no particular interest in or need for this. It's just that, I mean, I have experience with the whole NAT and firewall traversal aspect, so that's why I was asking. So it's, but I would recommend keeping it on the simple side and just go for what you really need. If you need bidirectional, yes, then you probably need to specify something. But trying to get this watertight is a lot of work, and I would recommend against it, but maybe some basic capabilities might be worth specifying here for those that need.
With my chair hat on, I think if this was to be adopted as a working group draft, that is the sort of topics that the working group would sort out and so on. Personally, I think this sounds like interesting work, but in light of time, because we want to get on to the next steps discussion in general, do you want to cover the COSI bit while you have the mic?
I
Brian?
can, yes. And this is covering a lot of the same ground as the last COSI BPSec presentation. The goals are all the same as what was discussed before, is keeping it as simple as possible. This is a glue between two existing protocols that are both well-defined enough that they both have some implementation and some logic about how they're supposed to operate. And it proposes a very simple set of, I'll show on the next slide, interoperability algorithms that follows very similarly from the BPSec default algorithms for symmetric keys, but it expands the scope to asymmetric keys. And that's really the big goal for this draft, is to allow existing asymmetric keyed algorithm behavior in as little effort as possible in the BPSec environment. And COSI is a very good fit because COSI itself is designed for that kind of store and forward transfers. There's no bidirectionality to it at all. And there is also some ongoing work in the COSI working group about PKIX and X509 transfers, and details to be worked out on the COSI side. But all the main points, all the main requirements exist already, at least as far as drafts to point at and explain how things are all to be done. And there's also a demo implementation that actually is doing bidirectional BPSec transfers with integrity checks, and it's working. At least all the pieces put together.
Brilliant. And again, I note from that you'd be interested in working group adoption as well, which seems like an obvious next step. Okay. Any questions on that from anyone? I don't hear any. So thank you very much, Brian. Thank you for keeping it nice and short as well. So next up we have Alberto Montilla from IPN-SIG, who wants to talk about interplanetary internet interoperability and management considerations. I shall click grant screen and let you drive your own slides. And I'll reset the clock on you as well.
Just give me 1 second. I'm having a, it seems I'm having a share issue here with the preferences.
I've got a copy of your slides if you decide to give up.
Okay, let me try and let me try here. Oops. Yeah, I might need your help because it's not letting me to do it.
Okay, let me try share screen. How's that? Can you see those?
Yep, I can see it. Thank you.
No trouble.
And good morning, good afternoon, everyone. My name is Alberto Montilla, although it says Alberto Bravo in the title. I'm a board member of IPN-SIG, the Interplanetary Networking Special Interest Group within the Internet Society. And I'm also a member of one of its working group, the Pilot Project Working Group, which I'm representing today. And also I'm a board member and CEO of Patent Corporation. My goal is to provide you our perspective, share a bit about what we are doing at IPN-SIG and draw some conclusions about it as well. Next slide. So the mission of the IPNC is no other than to help realizing a functional and scalable system of interplanetary data communications. And within that, we have an organization which tackles strategy, tackles experimentation, which is the pilot project group, also technical documentation, because one of our main goals is to advocate and promote the use and the technologies. So looking at any possibility for us to expand adoption of these technologies. So within the pilot project working group, we basically engage in research and prototyping opportunities to validate and extend the use of DTN. Couple of things. One is we look at the core of DTN in the sense of scale, interoperability, and management of DTN protocols. And second, we also experiment with use cases and applications, primarily to demonstrate the applicability of the protocol and also promote its use to space, which is well known, and also to Earth applications. I'm going to be talking today about some of the projects we're building. Primarily, our main goal is to build a DTN testbed, and we currently have active participation from many institutions and corporations. So we are we have very ambitious goals, but going step by step, which I'm going to talk about in a couple of minutes. And one thing is, we would like to share periodically our progress and, very important, our learnings with this community, and this is our first update. Next slide. So let's talk about the active projects. The first and main one is the DTN testbed. We basically are creating a network of networks. We have different institutions and corporations that are participating, each of them with their own networks. And the idea is that we create a platform in which a platform that is open to the general public to come in, learn, and also run certain experiments very specific to DTN. So things that are keeping us busy is looking at how we scale. So connecting not only tens of nodes, but our goal is to get to the hundreds, if not thousands of nodes as well, and look at interoperability in general, and then look at new features. So use the test bed also as a way to test some of the new features that are coming, or some of the proposals that are coming from the different organizations. And in addition to looking at the network level, we're also looking at different use cases, as you're going to see in a second. So all this started with a set of member projects, and the projects cover different areas, starting with a network management for space and Earth use cases. I lost the share.
Oh.
I can still see the screen, so I know that we're still sharing on this end.
Okay, perfect. I got it back. Thank you. So when we look at the member projects, starting with network management to basically manage DTN, and very specifically at this point, ion instances that could be in a space or on Earth. Looking at the different applications, the one project that is ongoing is the use of DTN to extend crisis information management systems with the use of rovers and the use of drones that are connected via DTN, and this is an Earth use case. We also are now in, or have incorporated, one of our members, and I'm going to talk about that in a second, have implemented a DTN system for reindeer husbandry, and that's in the Nordics, in the Arctic circle. I think the area belongs to Sweden, and this is a fully operational system as well. Things we have tried out: unified medical records for space exploration. There's a prototype build that basically takes information from the EMR database using SQL, and basically have a gateway that where those records can be sent to a space as needed. And the gateway also performs, curate the data, so only the critical data is sent back to, the remote area. And very recently, with the help of Google, we have been experimenting with connecting some machine learning or computer vision, I would say, computer vision algorithms to perform image recognition over DTN. And the goal is to basically, some of these applications, the goal is to understand the particularities of, how the application would work in, over long distances and things of that nature. Next slide. Then let me double click on a couple of things. I mentioned the DTN testbed late last year, November 27th. We were able to make the first connection, having few instances running, ION instances running on the Google Cloud, and that's basically managed by Google, including some sensors connected via MQTT, all using the bundled protocol version 7, connecting to the health information network deployment on AWS that have the medical gateway record as well. So this was a hello world demonstration, just a basic using basic BPv7 functionality, and that was the start of it. As of February, we have now 4 organizations on board, basically exchanging messages. Everything is ION based right now, but we basically welcome other implementations of the bundled protocol so that we can also do interpretability testing. We are exercising with, exchanging messaging files, recently starting with multicast, and we have put an image recognition prototype over DTN where a node can send an image, and then we'll get back basically what elements or objects have been identified. So one of the things is we're looking at the understanding of the extent of what use cases could be enabled, like identification of identification of elements within a picture or a video. So one thing that we learn straight away is that management is critical. Contacts and context plans are hard to manage and prone to error. Every single test session we have had, there was always, one EID that was wrong or one IP that was wrong. For a scale, the first thing is, having consistent management across the board, not only within the networks, but also between the networks is critical. And the other is that separating routing from management today is an interesting challenge, both from topology and as well as the exchange of contact information as well. So we're working on trying to understand how much governance and automation we need to continue this scale. Next step. Next slide, sorry. Thank you. The next point is, as we discover those challenges, we also continue the experimentation with network management, where we have a very, very early draft of a contact plan generator that the whole organization is using. But we also are experimenting with AMP as a way to basically transfer those contacts automatically to the different agents on the different nodes. And that's something that is keeping us busy right now, so that there is just a single place where all the organizations can go manage their networks and also manage the testbed, which is the interconnection of the networks in a dynamic fashion. Next slide. And this is the example of the unified medical records, very straightforward. Every corporation or institution on earth relies, or every person rely on their medical records hosted on an electronic medical record system, EMR or EHR, depending on where you live. There is a bunch of data typically using relational databases. The Health Information Network went ahead and created basically a prototype application to being able to put those records over, or curate those records, and being able to send those records over DTN. Next slide. And last but not least, on the ones we want to highlight, this is a project, as I said before, this is a project that it's fully in production. It was contracted by and is still run by the Dalvadis Economic Association back there in Sweden with the help of the Luleå University of Technology. And it incorporates the full stack from a series of LoRa radio stations all the way to the sensors and the DTN sensor, the DTN stack plus the sensors on the renders, all the way to an app where the hertz can be tracked and followed. This doesn't use ION. This use kind of a different version of a proprietary version of DTN. It doesn't rely on the bundled protocol. And a part of the discussions is understanding what it would take to get this to become, a standard implementation using standard protocols like BP. Next slide. And one thing, I want to highlight is if you think about the goal of IPNC, which is promoting the and extend the use of DTN protocols to have a reliable and scalable interplanetary internet, we are committed to standards. So right now, every test that we're doing is incorporating the bundled protocol version 7. As I said before, we are starting to experiment with AMP as a way to have a management framework for all the instances. And as we go forward, we continue identifying areas for further exploration and enhancements, such as multi-network or multi-region, if we want to talk about ION terms. Multi-agency routing and management is critical for scale. Network management is also critical for scale, and also better support for mobile use cases on the discovery and auto configuration front as well. Next slide. And last, this is the summary. So we're building the DTN testbed with participation from multiple institutions. We are learning a lot. Current learnings are very, telling us that there is still a big interdependency between DTN and the management, and this requires a time alignment to jointly evolve both protocols and frameworks. There is an opportunity to enhance the protocol stack by, management and routing options to enhance multi-network and multi-agency connectivity, and basically taking scale into consideration. And we're this for the long run, so we're committed to promote, experiment with, and augment the standard as needed. And last but not least, we would like to continue reporting the updates to this working group as needed. Thank you.
Thank you, Alberto. That was very interesting. And yes, of course, you would be welcome to continue reporting updates to this working group. I think multi-agency test beds being built and really testing at scale gives us very valuable feedback as we get into standardization. And I think it will be input into our next step conversation today, and will also guide what we think, considering you as effectively operators, it will guide what we as a working group look to standardize for interoperability at that sort of scale. So thank you very much. What I will do now is hand over to Ed, who wants to introduce the next steps. Ed, would you like me to share slides, or do you want to give it a try?
No, if you've already set up the sharing, I'm happy to not share.
Okay. I will click the button, as I'm becoming accomplished at this now, allegedly, and attempt to click the right tab. Working group, next step. So these are my slides, I must say, which is why they are hideously ugly. But on you go, Ed.
No worries. So what we did in preparation for this meeting was to go back through the set of new agenda topics that had come up through discussion over the past roughly year and a half, or maybe more. This past year has been a strange time for sure. At IETF's 105 and 106, in anticipation for finishing our initial set of working group charters, we had put out some calls to the working group associated with what do we think are candidates for next steps. In doing all of that, these are the things that came to the top that seem to have the consensus of the working group at that time. If we just sort of enumerate them or list them here quickly, we have bundle and bundle encapsulation, which is, again, as Scott had talked about earlier. There was a discussion of whether additional extension blocks were near-term needs, neighbor discovery, and right behind that, naming and addressing. The network management work, and then how many other additional security contexts and convergence layers, again, were needed in the short term. Next slide. In then looking through this, the comment both from us and from Magnus at the time was, that's an awful lot. It's very good work, but how do we prioritize this in terms of, again, near term over the next few years, and then that which follows? And we started to whittle it down and say there are things that are already actively being pursued. There's energy behind it, and there's a lot of work there, and we shouldn't let that go. So to that extent, of the things from the prior list, the ones that seem to have a lot of activity behind them right now are bundle and bundle encapsulation, the UDP convergence layer, some prior work that had been done on key administration, the AMP work, and then the COSI security context. And again, we just had the presentation on the COSI security context, more evidence that it is actively being worked. Next slide. So in all of this, and what we had devoted the second portion of this meeting for, was to walk through this list, ask to the working group, are there significant things that are missing, but then also to really come to understand what is the prioritization of this to inform the next charter. So to try and do that in an organized way, what we propose is we go through these topics, topic by topic, and we have some comments associated with them. We ask people to comment on those topics and also to suggest new topics. And then when this conversation is done, then we will take the compiled list out to the mailing list and finish it there, where we would then have the entirety of the mailing list and not just the folks who were able to attend today. And then, of course, the hope is that we will suggest that a final decision on the new charter will be confirmed at 1/11. Unless we think that we need more time based on the mailing list conversations. Additionally, it is likely that we may need additional interim meetings to talk through these things, and if so, we can certainly get them scheduled. Last part, and on the next slide, the topic breakdown, something that Rick and I propose as a way of helping to prioritize this work is, again, we mentioned before, there are some things for which there is already a lot of active involvement, and we certainly don't want to lose that energy and work that's already progressing. So to help us prioritize and not pick too much, but also not pick too little, is to come back and try and look at things in terms of existing work and extensions to existing work and things that are just brand new. And the idea is that we could take on a larger amount of existing work and extensions to existing work because these things are closer to being finished and farther along in being understood. And then things that are brand new work where we will spend significant time scoping, understanding, converging on things. Maybe we take on fewer of those because those are the kinds of things that could really eat up a lot of mailing list time, working group time, and could extend into multiple years. Which is, of course, not to say we should not take on new work. That's obviously a big part of things. But if we were to look back realistically and say, where's the likely complexity? The likely complexity is and concern would be that we would take on too many brand new things. And there are some new topics vital to get right. And at the end here, we've mentioned it again, naming and addressing is probably a big one. So then if we go to the next slide and say, these are the things that we have decided, are extensions to existing work, or we propose that they are the extensions to existing work. Again, bundle and bundle encapsulation is under active development and exists. The manifest block is part of open discussion, but it has been discussed prior. The UDP convergence layer is also being discussed, and also a mail convergence layer, which and an HTTP convergence layer is something that's come up several times. Convergence layers are extensions. We have put one convergence layer out. We have a sense of what convergence layers need to do. Bundle and bundle encapsulation is a convergence layer. And so these are all things that are repetitions on a theme. We already have a default security context that has gone out. If we add another security context, that certainly helps explain the concept of security context, and there's a lot of energy there. And then, of course, the asynchronous management work is also quite active and is existing work. So with that, with an idea of that which is new and that which is existing, and Rick, please correct me if you want to approach this in a different way. We were going to go slide by slide and talk through some of this, and then elicit any comments for each of these topics. And then when we get to the end, if there's anything that's missing, we would then discuss that as new items. Is that about right, Rick?
That was my plan. I think there is a danger if we stop constantly for people to say, "Oh, what about this subject?" Then we'll miss out an active discussion over the things we have already discussed at some length. So this slide on asynchronous management is just to say we've heard twice, maybe 3 times now today, that I'll turn my camera on for politeness. We've heard twice or maybe 3 times today from people saying management needs more work. We're really interested in AMP, So, and this is just to say, although we have a charter item already about the management architecture, and we have a draft which really is ready for last call. As an aside, that we will ask for last call after this meeting. There's work, there's energy, there's teams working on this. From my perspective, although it's existing, I think it really should go ahead. That's the only reason this slide is here. The rest of the slides are purely talking about the new items and breaking them down so that people get some idea of where the discussion is going. So carry on, Ed. I've interrupted.
No, that's good. So yes, agreed. There's a lot of the set of existing work. There's a lot of good work behind there, and I think that a lot of that should continue. I certainly heard the same message that management is something that we need to tackle here, and that it has unique parts to DTN. So I think that is fairly and firmly in scope for a recharter. And then I think we should talk through these new proposals. So,
do you want me to go ahead?
Oh, no, please. I talk plenty. Why don't you go through and talk through naming and addressing and so on?
Yeah, I'll start to peter out when it gets to sort of discovery. Okay, so naming addressing, there's quite a lot of detail on these slides, and I'll go reasonably quickly, but these are things that I believe should be tackled as part of naming and addressing. So on the surface, naming and addressing sounds really obvious because bundle protocol defines the IPN and the DTN EID format. It specifies how you put text characters in, what's valid, what's not, job's done. Where's the complexity? The complexity really is when you start to read between the lines of bundle protocol version 7 and the earlier bundle protocols. The concept of late binding of endpoints is very interesting. It starts to suggest that an endpoint is named, and the name doesn't necessarily give you any meta information of how to get a bundle to that name, so-called locator identity separation. Okay, so then if bundle names are semantic rather than location based, or they're purely an identifier, how do we locate them, etc., etc. So there's a lot of questions here. One of the other questions is, okay, we've got a DTN and we've got an IPN scheme. Are they global? Will the interplanetary internet have a single set of globally unique names? If so, who controls them? The schemes are controlled by IANA, the scheme registration. Does that extend to ICANN handing out in a sort of DNS style way? Is it a free-for-all? There's some open questions there that need to be addressed. And the bottom point here, which is entity IDs, an entity ID can refer, it can be a multicast entity. So giving you multicast anycast style capabilities. So it's not blindingly, well, that underlines my thought that there is locator identity separation going on here. This is a topic that needs careful thought, and many of these things need to be tackled. That's my pitch on naming and addressing. As a sort of addendum to that, as part of our current charter, there is an item called a registry of service identifiers. So this is the concept of, are there common bundle services, a bit like the common services you would get in your services file on a Unix machine, which says port 22 is SSH, port 80 is HTTP. Do we have common DTN services that we wish to update? I think there is an existing IANA registry. Do we wish to refresh that? Do we wish to do that sort of work? From that point, IPN has a concept of a service number as part of its definition. DTN doesn't. So that probably needs to be tackled at some point.
And Rick?
Yep.
Oh, I think we have somebody who joined the queue.
Oh, excellent. Sorry, I'm looking at the slides, not the queue. We have Marc Blanchet, who knows all about service identifiers. Go ahead, Marc.
Hello, do you hear me?
Yes.
Yes.
Yeah, I actually chatted the same thing, which is on the chat room. So a while ago, we discussed that we would do that work after, BP BIS is kind of, done, so that if anything related to it would have an impact on this thing, which we all thought it was, you should not, but, to be precautious. So I'm happy to resume that work and, do a new draft and working through the hurdles of this work. I think this is very important because right now there's kind of an implicit, things around around people deploying that is that they know what they're expecting, but in a general context of deploying, like you said, port numbers, we need to identify and standardize what we expect to receive where. So I think that's an important work, and I'm happy to start it.
Thank you. Yes, consider yourself volunteered. If the working group, actually, this is already a charter item, so you're quite within your rights to push something immediately. So right, I'm gonna keep going on this because I want to try and get to some discussion as well as these slides are possibly useful to go back to if people wish to raise explicit comments. Another topic that has come up over the years repeatedly is when we get BP7 out the way and BPSec, etc., we really ought to tackle neighbor discovery. So on my analysis, neighbor discovery is sort of divided actually into a couple of topics. There's neighbor discovery as a bundle protocol facility, so some kind of bundle protocol style ARP that says, I will send bundles across my one hop or whatever neighborhood to say, hey, I'm here, who are you, what have you got? Kind of an ARP analogy. Then if we've got service identifiers, do we use that as service discovery as well as node ID discovery, given endpoint IDs implicitly encapsulate services? Maybe. Also, there's the element that convergence layers, because they could well be running across IP, which has its own neighbor discovery mechanisms. Convergence layers may discover neighbors, possibly wouldn't discover DTN services at neighbors, but could probably discover node IDs. And that information could flow back up in a sort of event-driven way into the bundle protocol layer to say, hey, I got some neighbors if you're interested. Or do we need a hybrid approach where all of this gets tied together in a sort of lovely melange, which all just works beautifully? That's my thought about neighbor discovery, and it's more than one draft in my mind. Any comments on that, or I'll move on to the next one? Go ahead, Scott.
Oh, go ahead, Scott.
Scott, I just want to endorse the importance of this. I think the IP neighbor discovery protocol, for which we've had a draft for many years, is I think is an excellent starting point. And it seems to me that the core of neighbor discovery has to be discovery at the convergence layer, because bottom protocol, absent a convergence layer protocol, cannot hear anything, and so I don't know how it can converse. So I strongly endorse pursuing this. I think it's a really important charter item.
Thanks, Scott. Go ahead, Brian.
I was going to mention that I did play around a little bit with some neighbor discovery based on MANET and some other related protocols. And one of the updates to the UDP-CL would be to enable multicast type of discovery broadcasting that is similar in form and scope to the, like Scott said, IP neighbor discovery. But it would be at the BP layer, which enables a lot of things that BP takes care of, things that MANET has to do at a lower level.
Okay.
Which is interesting.
That sounds like there's such general interest and support there for the neighbors discovery tasks. So noted. What's the next slide? Is it more contentious? Yes, it's the big one. Routing. Okay. So as several people brought up in the IPN SIG and the ESA OPSAT implementation experiences, routing's really hard, but it has to happen. Otherwise, how on earth do we work out where or when to send these bundles? I know contact graph routing has been a stalwart, now named Sabre, from CCSDS. Profit has been around for a long time, has always sounded like it works brilliantly, but I'm not sure anyone's used it with Bundle Protocol version 7. I know there's a group in Korea who wanted to talk about it, but they're currently trying to resolve some IPR issues. I really hope they're listening and can come and talk to us at IETF 111. Because they had done some tweaks for BP7, which would be interesting. And I think we have to be realistic and say we haven't solved routing, and lots of people are itching to turn up with exciting routing ideas. So, as I say here, attempting to standardize one of these within the working group starting tomorrow, I think may be beyond our current bandwidth. I don't think we have sufficient bits and pieces together to try and get this done within a reasonable period of time. So my proposal would be to divide the problem into a forwarding problem and then a routing problem. And what I mean by that is, if you take a parallel from the IP world, and I know I'm teaching people to suck eggs because this is the IETF, a lot of the routing problems, they separate the information that a routing protocol builds into its routing information base, and the sum of whatever clever protocol evaluation that is performed is then placed into the forwarding information base of the system which actually moves the packets, you know, kind of the OS kernel or however, whatever your abstract image is. And I'm wondering whether it would be achievable and beneficial for the working group to try and define the forwarding information base in terms of these are the minimum things you need to have in that conceptual data structure. I'm I don't want to get into C implementation here, or Rust, or name your favorite language. I'm trying to say, to do forwarding, the bundle processing agent needs this information. Now, I think that might be achievable because it's alluded to in Bundle Protocol version 7, but quite rightly, Bundle version 7 at a certain point says this is out of scope. I think it might now start to be in scope, and it allows us to see how that forwarding table interacts with neighbor discovery and convergence layers and naming and addressing without having to work out how to do full end-to-end route and path tie down. I'm going to flip back to the actual. Yeah, Scott's in the queue. I knew someone was in the queue. Go ahead, Scott.
I think you're correct that this is a large thing to fight off right now. I think it's still a topic that is actively being researched, and I think there remain new ideas that can be discovered that can be applied to it. So I endorse the idea of like continuing to study this and pay a lot of attention to it and bring it up at these meetings, and yet not yet to commit to a particular target document production as part of the charter yet. One other thing I would like to say in connection with that is that I think multicast is an important element of the forwarding and routing, and also of the naming and addressing. It is a topic that is near and dear to my heart, and I think it might be productive to pursue multicast in the naming and addressing sort of area before plunging into what we do in terms of route computation.
I absolutely agree. I absolutely agree, because you're right about multicast, and I really wish I'd put a slide in now about it. Multicast touches addressing, as in how do we know it's a multicast group? It touches forwarding, as in when I'm trying to send a bundle address to something multicast, how do I forward that? And how do I know that I forwarded it to all the, and the group membership? So it affects neighbor discovery. How do I what is our equivalent of IGMP? How do I discover my multicast listeners effectively?
Right.
Great subject.
All of these things are closely intertwined, and I mean, we're doing things to address all of these in ION. Are those the right ideas? I don't know, but there would be things to offer as part of the discussion.
And this was one of the reasons I suggested that an interim, perhaps to just put all the naming and addressing discussion on the table and just chew that one subject to work out if we even had any kind of consensus at all. I think there might be some value in that. Again, interested in see what people's opinion is. I'm hearing good noises from Scott about forwarding. We'll see what everyone else has to say. What else have I got? Oh, sorry. I'm coughing.
Is then the sense that routing in general is not a topic that we should look at for the current charter, because it is complex and probably best tackled after we do naming and addressing to include multicast. So naming, addressing, and multicast should be in, but routing should not be in this next rev. That's what I took away from that, and I just wanted to make sure that is the right thing to be hearing.
Well, my proposal was that I don't think you can deal with naming, addressing, multicast, and neighbor discovery without pinning down some generalized concept, and this will populate the table used for forwarding.
I see.
And that was my point about just trying to get how routing protocols populate the forwarding information base is out of scope, but the existence and use of a forwarding information base for unicast and for multicast and for names that look like this and services that look like that are delivered locally, etc., etc. That, I think, we kind of are going to have to define it, and if we don't, we'll sort of automatically have to define it at the start of every document that really should refer to the standard definition, and they'll all slightly disagree.
Indeed.
But that might
Okay.
be, yeah. So very quickly summarizing, because I think this is the last slide I've got in the deck. As mentioned before, there's the DTN key administration work. I know Scott presented some work I think he'd been doing with Fred Templin on some really clever techniques for distributing keys. I mean, BPSec and the convergence layers require cryptographic material. If these networks are delayed and disrupted, then the keys still need to get there. Just relying on some unspecified out-of-band mechanism, okay, but it would be nice to have some protocols that do this, that run over BPSec, if over bundle protocol, if there's interest in doing it.
And we have Martin in.
Go ahead, Martin, I'm done. You're on mute, Martin.
There we go. Okay, much better.
Yeah.
I think I double-clicked muting for some reason.
Request to present.
Clarifying on the forwarding. So would it be in scope to have? So is it just the forwarding information base, or does that include how forwarding decisions are made, given that information? Like, does routing? Okay, go ahead.
This is Rick speaking personally. I think if you're defining the forwarding information base, you have to define how it's used. Otherwise, it's literally just a table. Here is some information in a table. It has to be driven by a use case and describe how one would use it.
Okay, so that seems logical. So we have the table and how to use it. What the canopy we are assuming here is how that data is populated.
Yeah, that's if I was writing this document, I would say how this table is populated is currently out of scope. And if neighbor discovery protocols want to say, and actually you can populate bits of the fib with the equivalent of linked local addresses or linked local scoped stuff, that's great. They can say, and this can be used to populate the following fields within the forwarding information base. So it's kind of, I could see it being informational. I don't think it needs to specify anything. I would say the fib would be an informational document to use as a reference point as part of the framework of forwarding and that discussion. So there's some consistency in terminology.
I mean, it seems like a sensible conceptual breakdown in my mind. The other related point I would make is I would ask that the charter consider the cross area consultation should happen, whether it be int area or routing area or whatever it is that's relevant to this. I mean, naming and so on. Thanks.
Point taken.
Agreed. Scott.
I like the idea of an informational document that describes the forwarding information base. I think establishing some concepts and some terminology would be very helpful. The other thing what I originally got into the queue for was to endorse certainly key management work as a
cool
item. I care deeply about it and I want to be involved.
Thanks, Scott. Zahed, hello, welcome. Our new AD.
Yes. Before, now we're open mic. I was thinking like maybe I should say it before you start the presentation. I'm describing all the topics, but help me understand the one thing. Like, I think this is mix of technical and like charter discussion, re-charter discussion. Like, there's a technical difficulties and what is included in the current charter or what needs re-chartering perhaps. Help me in this discussion to understand it better. Like, when you talk about discuss something on the topics, also perhaps bring the angle whether you guys think like working with things is within the charter or you need re-chartering for doing some of these new works.
So I was, from my perspective, I was really just going to raise the list of things we had previously talked about to the working group and say, everyone, we've been dancing around these topics, and as chairs, either myself and Ed or myself and Mark have said, not yet, because we need to get Bundle Protocol 7, BPSec, etc., TCP/CL out the door. Now they're gone. We've done them now. So we're now going to stop saying no to everything, but obviously we can't say yes to everything. But here is the list of all the things we said no to before. What do you, the working group, want to do? Which has to be ordered by not only interest, but also technical need. So we can't go off and all as a working group go and work on some crazy quantum-based probabilistic forwarding routing algorithm. Although it would be great if we can all get PhDs again. We'll never achieve anything. What we probably need to do is to tackle naming and how do we find our local neighbors and how do we decide what services those local neighbors have got, and which sounds on the surface really dull and boring because it's been solved for IP, but it isn't dull and boring for Bundle Protocol, and actually they're quite deep topics at times. They sound really obvious, but they need a bit of consideration. And it was almost a sort of trying to taste the water. Is there interest in the working group to do these things? So, and this is really everyone else in this meeting, and again on the mailing list later on. Can you give Zahed your feedback on what you... I know Scott's excited about doing stuff. I know Mark's excited about doing service identifiers. Is there interest from others? I'm going to do a poll. You go ahead, Ed. I'm going to find a poll.
We're setting that up. I just wanted to make the observation that when we looked at and started with Bundle Protocol version 6 and RFC 5050, again going back to 2002, there were a lot of deployments and lessons learned from that. And part of that working group was to take that set of work and then turn it into the non-experimental specifications. And because it has taken several years for that tail part of that process, we now have a case where some of these other activities have been up and running in various areas for a few years or more in reference implementation. In this case, I'm thinking of the network management, but also some of the routing work and so on. And we have experience with what needs to be done there. So I think for some of that, it is working through that backlog to make, based on the priority of how much effort and how close are they to finishing, and almost having part of that next recharter be like the original charter, which is take that body of work and finish it, and before we get into the things that are really sticky and difficult to work through.
Yeah, so let me just clarify myself a bit. I mean, I was reading the charter text and trying to understand what has been discussed so far today, and there was like a couple of things like the service registry and stuff like that. Those are already in the charter, right? And there are some existing architecture work and other things are already, you guys are, this working group is working on. But there are some new topics like COSE, if you need like key management, whether that's something people are interested in. So I was like, what I wanted to take advantage of today's discussion is like, if when you are discussing the technical discussion, technical interest, and whether something is needed, also might be a footnote saying like, this is perhaps needs some rechartering, so that I can record it for myself for further discussion. But that's the only thing. But I understand like if you want to only do the technical discussion and pull the interest of the working group, that's fine. We can come back to rechartering questions, whether it's including charter, current charter, or we need to recharter. Maybe we can revisit that one later on. That's fine.
So yeah, Zahed, I think that's a conversation the chairs and you can have between now and IETF 111, where perhaps we can propose a charter based on the simultaneous conversation within the working group about the technical aspects and the importance, and then at 111 we can decide whether a proposed new charter works, whether the ISG is happy to do that, blah, 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 if that works for you.
Yeah, sounds like a good plan for me.
Cool. Okay, so I've got Martin, another AD, Do you want to say a few words?
Sure. I'll have two completely unrelated points as irresponsible AD. Number one, that beyond just like what the group wants to work on, I think it's always important to ask what is actually ready. What are people like really dying to deploy? This is not a research group, so let's make sure there are clear applications. The other totally unrelated point is about convergence layers. If I understand correctly, the only thing we're considering doing is UDP-CL this at this point.
Currently, yes.
So the other thing okay, fair enough. The only thing I want to pitch here is TAPS. I don't know who here is aware of that. It is a different transport.
I'm not that aware of TAPS. I'm sorry.
No worries. So it's another transport working group that is also Heads actually, but I'm involved in it. But anyway, it is a generic API for applications to leverage whatever transports happen to be on the platform. They would just a very short pitch is that applications request certain characteristics, and then you would just go find whatever TLS library, whatever HTTP library, whatever TCP implementation, whatever. I mean, taking an expansive view of transport from HTTP and below. To include, TLS, etc. So anyway, the upshot of this is not sure how big it is, but I think that's a very fertile ground for something like this, where you could actually potentially build a generic convergence layer once and for all using something like this, and then platforms could use TAPS to go find whatever it has that fits the requirements for the application. So something.
Sorry, just questioning your TAPS summary. Does that mean an application can say, I need a transport with these sort of reliability characteristics, this sort of timeliness, blah, 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 as this sort of security, integrity, etc. That's interesting.
Exactly. Yeah. So just something to play. I mean, that doesn't sound like we're going to do a ton of convergence layer stuff in this round, but it's something I think that people should take a look at. A great entry point to this is the TSV area meeting from 109. So this is the last session. We had a talk very similar to Edward's today on DTN, but it was about TAPS by Brian Trammell. It was a good 30-minute discussion of what that's about if people don't want to just read a ton of text. Thanks.
Okay. Thanks, Martin. So I was putting a poll together very quickly, basically saying, is anyone interested in doing this work? Given the time, I'm wondering whether it's worth people, I'm going to check the chat, it's worth people putting forward any questions. I mean, it really is open mic. Technical questions, have we missed something? Are you itching to work on something that you think is vital that we have completely missed? Go ahead, Scott.
I'd like to get in a plug for quality of service again. That disappeared from bundle protocol. I think people are going to need it. Exactly what that is, I think is open to a lot of discussion, but I think we're going to need to have something. And that would be an additional extension block. And on that topic, I think the manifest extension block, as Ed pointed out a couple of months ago, is maybe obviated by BPSec because of the multi-target nature of bibs and BCBs. Who needs the manifest block to be able to do the job?
Yeah. Okay, I take your point on QoS. Completely missed that out, and yes, that's vital. And that opens the door to, okay, if you're going to do QoS, is it a 1-bit high priority, low priority switch, or is it a full MPLS style label switched, pinned down flow track model to allow transit networks? I think the answer is somewhere in between the two, because bundle and bundle can handle your segment routing if you want to do it. But yeah,
it's a wide open topic. I think it deserves a full airing.
Okay. As does heterogeneous naming. What happens when you want to address a DTN EID from an IPN host? And how do you get the message back, etc. So that's kind of that's name switching rather than netting. I don't know.
I see that as a routing question, but that's also something to spend a lot of time on.
Mm-hmm.
The last thing I was going to bring up as a question is, do we think that there is value in planning now for an interim meeting to sort of force the discussions on the working group in anticipation of an interim meeting, so that we can then have a down select to then better inform the next working group meeting at the next IETF? And just wanted to know if there was any concerns about the ability to support that.
Right, I've just started a very quick poll to allow you to raise your hand or whatever to say.
And Mark is in the queue.
Go ahead,
Go ahead, Mark. You might be muted. So we don't hear anything. So maybe Rick, is the poll for an interim meeting, or is the poll for?
The poll is for an interim meeting. It's would you attend an interim meeting before July? And I'm seeing, of the 30 odd participants, I'm seeing a 5 positive. Yeah. Okay. Well, I'll let that tickle along because we're heading towards the end of the session. Where is the poll? So the poll, there is a polls tab somewhere. I don't know. Obviously, as a chair, you get a slightly different user interface experience, but
it's the bar graph icon in the upper right of the screen.
Thank you very much. It's the bar graph icon on the top right of the screen.
It's the 5th from the left.
Yeah. So really the session is coming to a close. Luckily, they keep the microphone open for a little bit longer. I'm going to watch the queue, and what I'm seeing is an overwhelmingly positive yes, they would attend an interim. I think, as Ed and I mentioned before, an interim would be a sort of cards on the table discussion about probably naming and addressing, because I think that drifts into neighbours quite easily. But we can discuss the actual content of the interim on the list between now and a sort of midway between now and IETF 111 would be my proposal for when to hold the interim. Ed, do you have any closing comments? And I am going to end that.
Nope, no closing comments other than thank you to everyone who presented. Thank you for everyone for your attention, and please be active on the working group mailing lists, particularly as we go into that interim discussion, because we recharter infrequently, and it is important that we get the priorities of these things correct.
And equally, watch the mailing list, because we will be asking for some working group adoption on behalf of the authors of a couple of drafts. So there'll be, in the next couple of days, a bit of a flurry of emails saying working group adoption, yay or nay. So please let us have your feedback on that. As usual, assent is assumed as a silence is assumed as assent. But otherwise, enjoy the rest of your IETF. Thank you very much for attending, and I will speak to you at an interim by the sound of it, which sounds great.
Bye-bye.
Thanks all. I'm shutting the session.